this chain rule in the function of one variable, and we'll pick the idea from there and we extend it to the function of more than one variable. I take an example. For example, I'm given here y is equal to 2x squared plus 5x plus 10 to power 9. So here this I want to find the derivative of this one. To find the derivative of this one, I just take it that I take here u is equal to 2x squared plus 5x plus 10. Now my y, I can write here y equal to u to power 9, where u is also some function of x. So, and over u, we haven't defined this one. We don't need to write it some function of x. But we know what's u. Our u is equal to 2x squared. We have already defined u above. So our u is equal to 2x squared and plus 5x plus 10. Now I want to find the derivative of this one. I write here dy by dx. So we write like this one. We divide by u du and we multiply by du. So we can rewrite dy by dx as dy by du and du by dx. Now if I apply this one, so we can see it like this one. This here is my y, then this is my u, and this is my x. So when we take derivative between this one, we get here dy by du, and derivative this 2, I get here du by dx. This is my chain. So here you can say this is my chain from y to u and u to x. Now I can find the derivative. This is 9 u to power 8 using the power rule, and then we apply our derivative formula here. We get here 4x plus 5. So we substitute the value of u. So I can write my dy by dx is equal to 9. I substitute the value of u. This is 2x squared plus 5x plus 10 to power 8 into 4x plus 5. So that's my derivative. So I can write this derivative directly. So I know here that we have the formulas very easily we can find, and y is given equal to 2x squared plus 5x plus 10 to power 9. So we are having inside and outside. So my dy by dx, as we are applying the formula, 9 into 2x squared plus 5x plus 10 to power 9 plus 1 is 8, into derivative inside, that is 4x plus 5. So we can do it also by this way. But in case of function of 2 variables or 3 variables, the things will be different. Now we are going to define this chain rule for function of 2 variables. I am having here the given function. I have the function u, w is given to me a function of w is a function of u and v. What's my u? My u is a function of x and y. What's my v? My v is a function of x and y. Now I want to find the derivative partial w by partial x. Now partial w by partial x is equal to partial w by partial u into partial u by partial x. Now again we have one more variable v. So we say partial w by partial v into partial v by partial x. So similar to this one, because for u is a function of x and y, so we can define the derivative with respect to y also. I can say partial w by partial y is equal to partial w by partial u into partial u by partial y, partial y plus partial w by partial v into partial v by partial y. I can show this one in a graphical form. This is my w, and my w is a function of u and v. This is my u, and this is my v. Now my u is a function of x, and my u is a function of y. Also v is a function of x, and v is a function of y. Now when I want to find partial w partial u, so my path will be from w to u and from u to x, one path. Second path will be w to v, and from v to x will be the second path. So this is how I can define partial w by partial x. So first from the path of u and path of v. If I'm going to find partial w by partial y, so then by w partial y, I'll get here one path, that is from u, w to u and w to v. Then from u to y and from v to y. That's how we can describe the chain rule in case of function of 2 variables. I give you the example to explain it further. I'll give you an example. We apply our chain rule. Our given function is w is equal to function of u and v, u cube plus v squared. And our u is the function of xy is xy squared, and v is the function xy is x squared sine y. We want to find partial w partial x and partial w partial y as defined in our last example. where the formula for that one is partial w by partial x is equal to partial w by partial u into partial u by partial x plus partial w by partial v into partial v by partial x. So we take our partial derivative. Partial w partial u will be here. U is changing, v is not changing, v is a constant. We get 3u square, and then partial u by partial x. Here y is not changing, x is changing, is equal to 1. We get here y square plus partial w by partial v. Now u with the function of u is a constant, v is changing. So get here 2v in partial v by partial x. And here we get here x square is 2x sine y. Note this because we have the original function, a function of u and v. So we change the variables u and v. Function is x and y. So we change variable u and v in x and y. So I can write here this is equal to 3 into u square. U square will be x y square whole square into y square plus v is 2 into x square sine y into 2x sine y. So I simplify this one. I'll get here the value of partial w by partial x is equal to 3 into x square. Y square will become y4 into y, it will be y6 plus 2 into 2 is 4. X square into x is x cube, and sine y into sine y is sine square y. So this is my partial w partial x. I want to find partial w partial y. We have the same. We write the formula. We are having here partial w by partial y is equal to partial w partial u into partial u by partial y. Then we have in the second term partial w by partial v into partial v by partial y, exactly as before. Our w is equal to u cube plus v square, and partial w partial u will be equal to 3u square plus 0, and partial w partial v will be equal to 2v plus 0. So we can write here this is equal to 3u square, and then we plus here we are having here 2v, and now we partial u by partial y. U by partial y is xy square. X is constant, y is changing with 2y. We get here 2xy, and then partial v by partial y. Partial v partial y, v is equal to x square sine y. With respect to y, we get here derivative of sine y is cosine y. So I'll get here x square cosine y. Again, I replace my u and v. I get 3 into xy square whole square into 2xy plus 2v, or v is equal to x sine y into x square cosine y. You simplify this one. We get here 2 into 3 is 6. X square into x is x cube. Y square whole square is y to the power 4 into y is y to the power 5 plus 2. We get here x square is x to the power 4. We get here sine y into cosine y. So this means that if you want to write here 2 sine y cosine y is equal to sine 2y, you can write it, but if you can leave it like this one, it's also the complete result.